Hello, my name is Matias del Campo. I'm Associate Professor of Architecture at the University of Michigan, Tubman College, and I run together with Sandra Manning at the practice SPAN. Today, I would like to talk a little bit about a topic that Sandra and I have been looking into for the last couple of years, specifically methods and methodologies of implementing artificial intelligence as a design technique in architecture. Very fittingly to the conversation today, and thank you very much for the invitation to talk today here at the LASG, is the conversation about living architecture in synthetic ecologies, something that Sandra and I have been looking into for a while. I would like to keep certain things a little bit short, so I apologize for simplifying certain problems. But first of all, we have to, of course, look into what is artificial intelligence, because everyone is talking about it, but it's a whole set of things. It's not just one thing. There's different techniques that are getting applied. They include neural networks, adversarial generative networks, machine learning, deep learning. So there's like a whole set of things that are around and tools that can be applied to this problem. But it actually goes down to three specific questions that an AI has to address, which is, on the one side, intentionality, intelligence, and that's a matter of definition, of course, and adaptability. So these three aspects have to be fulfilled in an artificial intelligence to operate in a specific way. Then the next question is, why should we use AI at all, right? And the main answer to that is rather primitive but simple, because it's easier to teach machines how to do things, how to learn, rather than how to do things. So specifying just one-by-one task is more difficult than teaching the machine how to learn how to fulfill specific tasks. So also in that area, there are two specific trajectories. One is the generalized AI. And there you can think about machines like, let's say, Data in Star Trek, or the Agent Smith in The Matrix. So these are all machines that actually can do everything, right? They perform human, they can do specific different tasks, they can do everything. And then the applied AI, which is just fulfilling one specific task. Yeah? And the majority of research right now in AI is about applied AI. So they actually really go for one specific problem. And I want to illustrate that with one problem that you all know. When you fill out bank checks with your numbers, machines are reading those checks to read the numbers. And there is a specific way how to do it, in that there is a generative adversarial network that actually learns, or actually you train that network to understand what is a 6, what is an 8, what is a 1. And then the more of these images are implemented in this system, the better that AI can start reading those numbers. And by now, because we have millions and millions and millions of examples for numbers written by humans, AIs can recognize with a very high accuracy which numbers are written on your check. So that just to show that the most simple way of understanding AI. Of course, I have to show this here. This is the largest laboratory for outdoor autonomous car driving testing at the University of Michigan. And the story why I'm showing this is, on the one side, to demonstrate that these aspects are getting implemented more and more in our everyday life. By the way, AIs are getting implemented you probably get in touch with AIs all the time right now. Like, you think, for example, about when you're searching for things in Amazon and you get like all these proposals of other things you might like, it's because an AI is actually learning basically your taste, so to speak, and is proposing things. It's a learning process. So this largest outdoor testing ground is something that came very handy in the ways how we operate studios now at the University of Michigan, because we could get in touch with people from the robotics department who are really specialists in artificial intelligence and are helping us understanding how we can apply certain aspects of these processes in our own architectural designs. So this is basically how a car, for example, would see its environment. This is all based on LiDAR and methods of reading how distances are reflected by a LiDAR sensor. They are in itself, I think, already pieces of art, and I actually think this is quite a fantastic way of perceiving the world. And perception, I think, is also one of the things that constitutes an artificial ecology. Now, how are these kind of things getting used today in architecture? We all know these examples of, for example, the Nest, an intelligent or rather intelligent thermostat that understands how you perform. Of course, scanning 3D environments. And then, for example, creating adversarial networks that are able to generate on its own facade variations. And this is getting used by specific companies, like, for example, XCool in Shenzhen, who use these techniques basically to optimize developer projects in China, which is kind of scary, I have to say, but it works for them. And other approaches where you use rather playful approaches, like Jose Sanchez Blockhood, that also implements specific aspects of artificial intelligence in the way of it's actually discussing methodologies of aggregating architectural componentry. Now, there's another aspect to this, which is AI and creativity. This is a page from Bob and Ellis, which are two AIs discussing aspects of economy with each other. And it's a famous experiment where actually the people doing the experiments went away, came back the next day, and the AIs had developed their own language, which was not readable for humans anymore, which I think is an instance of a creative process of going around the language and developing a completely new one. And the aspects of machine hallucination, which I think is also very informative in for example, how Deep Dream starts to read features of birds in a Van Gogh painting. Yeah? This is basically training an AI to read in every sort of imagery you give him features of birds. And where does this go to? Style transfer, for example, where you can basically generate your own Van Gogh painting. Right now, already this is getting recognized as a new method of art. This painting here was actually created by an AI and was recently sold at Sotheby's for $500,000. So we are getting actually at the point where we are accepting that there is another cultural agent in place right now. And because of this whole conversation of style, I actually like the idea that the idea of style getting a return into the architectural discourse. The same in literature. The first AI-generated poem, sorry, it's in German. Same in music. And here I would like to show one example of our work implementing these sort of ideas. In this case, the ceiling for our proposal for the Austrian pavilion at the Dubai Expo, where we use style transfer to create a combination between a Baroque ceiling and a modern ceiling. And the resulting model is what you see here in the ceiling. Same for this chapel, so where we also use style transfer to create the model for this here. It's still for us an ongoing research and an ongoing process of how to really apply it. It's the first steps to get there. I'm going to jump over this one. But here's a little example of how it works. So this is just a normal Hong Kong facade, the repetitive facade we all know. It's very iconic. And then the iconic image of a Baroque chapel in Germany, and that's what you get in the combination of both. So actually it really starts to read the features of modern architecture within a Baroque environment. And then the problem of translating that into 3D, this is sort of like one of the most pressing problems for us, is really translating imagery into 3D models. And this is where we're using another neural renderer that is able to transform imagery into 3D models. Examples from our studio. And again, this sort of translation of this imagery, this is actually from a studio that I taught at UPenn a year ago, and it's the work of the students Mariana Sanchez and Li Ti Wang, who were really able to develop a very sophisticated methodology of applying this sort of 3D meshes and the generative adversarial network approach to a deeper project. And I'm happy that I can say that we are currently working on a project for the University of Michigan where we're going to apply this methodology on a construction site. And with this image, I would like to end my presentation. Thank you very much for listening. Thank you. I rushed through. I think we have a bit of time for questions. Yes. I know I rushed through the whole thing very quickly. Yeah. This would be like an hour lecture normally. Yes, please. Who's first? Oh, okay, sorry.
Sorry, I'll be short. Your work reminds me of Mark Foster Gage, obviously, with his sort of pastiche. He's taking a more pop art, in my interpretation, How does yours different than
Yeah.
that? Is it taking a more systematic approach to solving performative problems?
Actually, I would say it's the other way around.
Oh,
Yeah, just to make that clear. So Mark's approach is certainly different than mine. I think that, first of all, Mark does not apply at all any scientific method in terms of applying artificial intelligence to anything. Yeah? I mean, I don't know if pop art is the right way. It's certainly more a collage approach, and mine is rather more something that is rather closer to a composite, where you really try to embed these two pieces of information into one new piece. So it generates something novel, versus having discrete pieces that you put together where you really see the seams between whatever you're creating. I would say this is a major difference. But I'm sure that we probably both come from a similar aesthetic background. Yeah. I think you had a question, right? Does that answer your question? Yeah, okay.
Hello. My question is, well, you are actually using recently AI just... I'm very excited about your projects, firstly, because I have been dealing with machine learning for a long time now, and applications of machine learning in early design phase. So, but I kind of have the feeling that you are working a lot with surfaces, and kind of definition of the surface is a kind of a new generation of an environment. However, I would like to know about your reflections about how to state your problems, how to actually, instead of just taking an image-based domain and converting it to a three-dimensional mesh, how would you actually state an architectural problem, represent an architectural problem to the AI? I think this was kind of the main question I was asking myself in my own research. So can you reflect on that a little bit?
Yeah, that's an excellent question. I have the feeling that we're just at the beginning of the development of what is possible actually with neural networks and generative adversarial networks in terms of architectural design. But especially generative adversarial networks are really exciting to me because they're about training. So basically, we could train an AI to recognize architectural features in almost everything. It just depends on the information we input, as usual. Garbage in, garbage out if we don't do it right. But imagine the situation where, and this is the next step that I'm trying to do, where I actually create databases of plans throughout history of architecture. And these are thousands and thousands and thousands of images of plans that are defined in different criteria, right? It could be that it's, for example, types, typologies. It could be that specific rooms. It could be that it's specific details, right? So you can actually generate this enormous amount of databases that are based on information we already have, and train an AI to say, here is your plot. Yeah? Here's the environmental data. Start generating something out of the one photograph that you have from that plot. So the possibility to train an AI really to generate plans, yeah, is for me something that I think is quite exciting. We are currently training an AI to recognize in any sort of imagery architectural features. That's another option. So there's like a variety of possibilities there.